Today we will learn everything that we need to know to build full-stack application. On the screen you can see the simplest possible full-stack application that you may build. When you click this button, API is invoked and request is being sent to the backend. Backend receives it, processes it, sends back the response, and UI displays it here for the user. It's a very simple program, but the configuration for it is the same as for large scalable enterprise application. So no matter level you are at and what kind of application you want to build, this setup will serve you well because it's very solid and scalable. And once you learn this configuration, you can build your backend and frontend independently and test them together. So whether you are a backend engineer trying to learn a little bit more about the frontend or the opposite, if you want to be full stack, this video is for you. For those of you who are new here, my name is Katya, and on this channel I help you solve coding and software problems so that you can be more efficient, suffer less, and move forward with your projects faster. Without further ado, let's dive into configuration. We will set up front-end in WebStorm using React and TypeScript and the backend in IntelliJ IDEA using Spring Boot and Java, and we will configure them to talk to each other using APIs. In this section, we will set up the backend of our application. We will use IntelliJ IDEA as our code editor, Spring Boot as the framework that handles configuration and application setup, and Java as the programming language. To follow along, make sure you have IntelliJ IDEA and Java installed. The setup for those is very simple. To install IntelliJ IDEA, you should go to JetBrains website, download the installer and follow the installation instructions. To install Java, visit the Oracle website and download the JDK. You can also follow my step-by-step video guide, which I created and I linked in the description of this video. Okay, so once everything is installed, open IntelliJ IDEA and click New Project. Select Spring Boot as the framework, then choose a build system. I usually use Maven, but for this exercise, this choice doesn't matter. Select the Java version and click Next. In the next step, we will choose the required dependencies, so all external libraries that our project needs to run successfully. For our basic setup, select Spring Web and Lombok. And don't worry too much about this part up front. We can always add extra dependencies later if needed. Click Create to generate the project. After a while, IntelliJ will create a Spring Boot application that is ready to run. To run it, click the green arrow next to the main application class and the server will start. Once the application starts, you should see a message here indicating that the server is running on port 8080, which is a default. Now open your browser and navigate to localhost 8080. You should see such page. This page, although that it looks like an error, confirms that the application is actually running successfully. If the application was not running, the browser would display a site cannot be reached error instead. But to show you that it's really working, we can create our first API endpoint. For this reason, we create a controller. In Spring Boot, a controller is responsible for receiving HTTP requests and routing them to the correct application logic. It acts as the bridge between the frontend or API consumer and the backend logic. So when frontend says, "Hey, I want to get a list of all users," HTTP request is being sent to API point, which is API/users. The controller receives that request and knows exactly where to route it, meaning which Java class and service should handle it in order to retrieve the users. So above the controller class, we are going to add a couple of Spring Boot annotations. We'll use REST controller and request mapping to tell Spring Boot which URL this controller is responsible for. For now, we will keep it simple and just use generic /API path. Later on, when your application grows, you will usually make this more specific, like /users, /orders, or /documents, and so on, and have a separate controller for each of these. And of course, required args constructor from Lombok. Alright, now we can add our first method. We'll call it getHello, and for now it will just return a simple string. Above the method, we need to tell Spring what kind of HTTP request this is. which in our case is a GET request, and also define the rest of the URL path. So when we put everything together, the full endpoint will be /API/hello. At this point, we can restart the application, open the browser, and type the full URL here. And you should see the response come back. That's how we know everything is wired up correctly. Now, one last small improvement. Instead of returning a plain string here, we want to return JSON, which is the standard format for APIs. Spring Boot uses the JSON library behind the scenes to automatically convert Java objects into JSON for us. So we don't have to do anything special here. And of course, instead of using GET, we can use any HTTP method here. For example, let's say that our frontend button will be sending some data to us, so we would use POST method and rename API endpoint to something like /send. Remember to restart the application after every change. And that's basically it for the backend setup. Our API is now ready to send data to clients. So next, let's move on to building the frontend. Setting up the frontend. For this section, you will need WebStorm and Node.js installed. WebStorm IDE is available on JetBrains website, and for Node.js, you can go to official site for Node.js and download the installer. First, open WebStorm and create a new project. Here you will see a few options. You can select React directly, which still works, but is no longer the recommended approach. Instead, we will use Vite. Vite is a new build tool for React application. It's faster, much simpler to configure, and makes local development much easier. Choose your Node version, select the React template, and make sure to check the TypeScript option. Once you create a project, WebStorm will generate everything for us. Before we start the server, WebStorm will prompt us to run npm install. Go ahead and do that. This just downloads all the dependencies the project needs. You might see a warning here about your Node version if it's a bit older. That's totally fine, it's just a warning. The project will still run and we can upgrade Node later if needed. Now let's start the app. You can either run npm run dev in the terminal or simply click this npm dev button at the top. Once it's running, Vite will give us a default URL, localhost 5173. Because we use the template, we will see a sample React page right away. For the purpose of this video, I will simplify things here. I will delete most of the generated components and keep only what we need to demonstrate communication with the backend. I'm removing all the counter logic and leaving just a header and a button. Our simplified component is ready. Now, when I click the button, nothing happens, which is exactly what we want at this stage. Alright, so from here, our goal is simple. When we click this button, we want to send a request to the backend and get a response back and display it in UI. Remember the API endpoint we created earlier in the backend section? Let's fetch that endpoint from our frontend and just display the response in an alert for now. Our backend is already running, so let's reload the frontend and click the button. We can see that the request was sent by seeing 200 code, but it failed because it's blocked by the course policy. This is a browser security rule that controls which websites are allowed to call our backend APIs. Currently, our backend is not set up to allow requests from localhost 5173. So to fix this, we have to go back to the backend and add the cross-origin annotation above our controller, specifying localhost 5173. And remember to restart the backend again after you do this. Now let's try again. Click the button, and this time it works. We get our response in the alert. At this point, we can do whatever we want with the response. Instead of using an alert, we can store the response in React state. We'll use the useState hook to save the response when we fetch it, and then display it in another component. Once it's done, we can remove the alert. And now we have a clean front-end to back-end connection in place. And one last thing. You may have noticed that we hard-coded our endpoints both in the backend and front-end. That is not a good practice because if it's in the code, you will have to repeat it every time we use APIs. So one last thing that we will do is to add our local hosts to configurations, both in front-end and backend, so that we don't have to repeat it every time we invoke API. So for front-end, go to vid.config.ts. Here we will configure the server proxy settings so that all API calls are automatically forwarded to our backend. This lets us avoid hard-coding the backend URL in our React code, and now we can delete it from here. On the backend, we will do something similar by creating a dedicated configuration class. We'll call it course config, and this is where we will define all allowed URLs, HTTP methods, and headers in one place. Once that's done, we no longer need the cross-origin annotation on our controllers. So we can remove it, restart the backend, and we can see that everything still works exactly the same. And that's it. From here, you can take your application wherever you want. You can continue developing your backend and frontend independently and test them together as a full stack application. I will be recording more full stack examples very soon, so if you are interested in that kind of content, make sure to subscribe. And as always, happy coding, guys!